Hello everyone, welcome to day 18 of reading NestJS documentation almost every day because I may have missed a couple of days so far, and but as always we're making a good progress here. We're at the end of fundamentals and we'll be moving on to techniques afterwards. So Consistency matters. Showing up every day matters. For those of you that are new here, make sure to like and subscribe. And overriding globally registered enhancers. So this is with testing. If you have a globally registered guard or pipe, interceptor or filter, you need to take a few more steps to override that enhancer. To recap, the original registration looks like this. Providers provide app guard, use class JWT auth guard. This is registering the guard as a multi-provider through the app start token to be able to replace the JWT auth guard here. The registration needs to use an existing provider in this slot. Providers provide app guard, use existing, JWT auth guard. Notice the use of use existing instead of use class here. JWT auth guard. Hint: change the use class to use existing to reference a registered provider instead of having Nest instantiate it behind the token. Now the JWT auth guard is visible to a Nest as a regular provider that can be overridden when creating the testing module. Const module ref await test create testing module imports app module override provider JWT auth guard use class mock auth guard compile. Now all your tests will use the mock auth guard on every request. Testing request scoped instances. Request scoped providers are created uniquely for each incoming request. The instance is garbage collected after the request has completed processing. This poses a problem because we can't access a dependency injection subtree generated specifically for a tested request. We know, based on the sections above, that the resolve method can be used to retrieve dynamically instantiated class, also as described here. We know we can pass a unique context identifier to control the lifecycle of a DI container subtree. How do we leverage this in a testing context? The strategy is to generate a context identifier beforehand and force Nest to use this particular ID to create a subtree for all incoming requests. In this way, we will be able to retrieve instances created for a tested request. To accomplish this, use just spy on the context ID factory. Constant context ID factory create just spy on context ID factory get by request mock implementation which we give an anonymous function as an input where the output is the context ID. Now we can use the context ID to access a single generated DI container subtree for any subsequent request. Cat service await module ref resolve cat service context ID. Okay, so that was the end of fundamentals. That was the end of the testing, and that was the end of the fundamentals. And now we will be moving on to techniques. There are a lot to cover here because there are a lot of techniques to learn, of course, that's relevant to the backend development. And we're starting with configuration. Applications often run in different environments. Depending on the environment, different configuration settings should be used. For example, using the local environment relies on specific database credentials, valid only for the local DB instance. The production environment would use a separate set of DB credentials. Since configuration variables change, best practice is to store configuration variables in the environment. Externally defined environment variables are visible inside Node.js through the process env global. We could try to solve the problem of multiple environments by setting the environment variable separately in each environment. This can quickly get unwieldy, especially in the development and testing environments where these values need to be easily mocked and or changed. In Node.js application, it's common to use .env files, holding key value pairs where each key represents a particular value. To represent each environment, running an app in different environments is then just a matter of swapping the correct .env file. A good approach for using this technique in Nest is to create a config module that exposes config service which loads the appropriate .env file. While you may choose to write such a module yourself, for convenience, Nest provides the NestJS config package out of the box. We'll cover this package in the current chapter. Installation. To begin using it, we first install the required dependency npm install save NestJS config. Hint, the NestJS config package internally uses .env. Note, NestJS config requires TypeScript 4.1 or later. Getting started. Once the installation process is complete, we can import the config module. Typically, we'll import it into the root app module and control its behavior using the for_root static method. During this step, environment variable key value pairs are parsed and resolved. Later, we'll see several options for accessing the config service class of the config module in our other feature modules. Actually, I might write this down because I might make a note of it to look at my repository, because I don't think I'm using it this way, because I feel like I'm just using regular Node.js way to import these environment variables. But yeah, it's good to follow these practices. App module TS. Module imports. Config module for root. Export class app module. The above code will load and parse an .env file from your default location. Merge key value pairs from the .env file with environment variables assigned to process.env and store the result in private structure that you can access through the config service. The for_root method registers the config service provider, which provides a get method for reading these parsed merged configuration variables. Since NestJS config relies on .env, it uses that package's rules for resolving conflicts in environment variable names. When a key exists both in the runtime environment as an environment variables, for example via OS shell exports like export database user is test, and in a .env file, the runtime environment variable takes precedence. A sample .env file looks something like this: database user test, database password test. If you need some env variables to be available even before the config module is loaded and Nest application is bootstrapped, for example, to pass the microservice configuration to the Nest factory create microservice method, you can use --env file option of the Nest CLI. This option allows you to specify the path to the .env file that should be loaded before the application starts. --env file flag support was introduced in Node version 20. See the documentation for more details. Nest start --env file.env. Custom env file path. By default, the package looks for a .env file in the root directory of the application. To specify another part of the .env file, set the env file path property of an options object you passed to for_root as follows. So configure module for root env file path .development.env. You can also specify multiple paths for .env file like this. Config module.for_root env file path .env development.local .env.development. If a variable is found in multiple files, the first one takes precedence. Disable env variables loading. If you don't want to load the .env file, but instead you would like to simply access environment variables from the runtime environment, as with OS shell exports like export database user equals test, set the options object ignore env file property to true as follows. Config module for root ignore env file true. Use module globally. When you want to use config module in other modules, you will need to import it, as is standard with any Nest module. Alternatively, declare it as a global module by setting the options objects is global property to true, as shown below. In this case, you will not need to import config module in other modules once it's been loaded in the root modules, for example, app module. Config module.for_root is global is true. Custom configuration files. For more complex projects, you may utilize custom configuration files to return nested configuration objects. This allows you to group related configuration settings by function. For example, database related settings, and to store related settings in individual files to help manage them independently. A custom configuration file exports a factory function that returns a configuration object. The configuration object can be any arbitrarily nested plain JavaScript object. The process.env object will contain the fully resolved environment variable key value pairs with .env file and externally defined variables resolved and merged as described above. Since you control the returned configuration object, you can add any required logic to cast values to an appropriate type, set the default values, etc. For example, config configuration ts export default, and we pass on a function here where the output is an object that includes port, parse int process.env port, database, which is an object, is the value, host, process env database host, port, parse int process env database port, database port. We load this file using the load property of the options object we passed to the config module.forRoot method. Module imports config module for root load configuration. Notice the value assigned to the load property is an array, allowing you to load multiple configuration files. For example, load database config and also auto config. With custom configuration files, we can also manage custom files such as YAML files. Here's an example of a configuration using YAML format. HTTP host localhost port 8080, DB Postgres URL localhost port 5432, database YAML DB, SQLite database SQLite.db. To read and parse YAML files, we can leverage the JS YAML package. npm install JS YAML, npm install types JS YAML. Once the package is installed, we use the YAML load function to load the YAML file we just created above. Constant YAML config file name, config.yaml, export default, return YAML load, read file sync, join, directory name, YAML config file name, UTF-8 as record string any. NestCLI does not automatically move your assets non-TS files to the dist folder using the build process. To make sure that your YAML files are copied, you have to specify in the compiler options asset objects in the NestCLI JSON file. As an example, if the config folder is at the same level as the src folder, add compiler options assets with the value assets include config YAML, out directory, dist config, read more here. Just a quick note, configuration files aren't automatically validated even if you are using the validation schema option in NestJS's config module. If you need validation or want to apply any transformations, you'll have to handle that within the factory function where you have complete control over the configuration object. This allows you to implement any custom validation logic as needed. For example, if you want to ensure that port is within a certain range, you can add validation step to the factory function. Export default const config YAML load, read file sync join directory name, YAML config file name UTF-8 as record string any. If config HTTP port is less than 1024 or over 49,151 and it throws error, return config. Now if the port is outside the specified range, the application will throw an error during startup. Using the config service. To access configuration values from our config service, we first need to inject config service. As with any provider, we need to import its containing module, the config module, into the module that will use it. Unless you have the isGlobal property in the options object passed to the config module.forRoot method to true. Import it into a feature module as shown below. So feature module TS module imports config module. Then we can inject it using the standard constructor injection. Constructor private config service, which is of the type config service. Hint, the config service is imported from the NestJS config package and use it in our class. So this is how we get an environment variable, const db user, this the config service.get string database user. Get a custom configuration value, const db host, this config service get string database host. As shown above, use the config service.get method to get a simple environment variable by passing the variable name. You can do TypeScript type hinting by passing the type as shown above. For example, get string, ... The get method can also traverse a nested custom configuration object created via a custom configuration file, as shown in the second example above. You can also get the whole nested custom configuration object using an interface as the type hint. Interface database config host string port number const dbconfig this config service.get database config, that's the type, and database is the input. You can now use dbconfig.port and dbconfig.host. For example, const port equals to dbconfig.port. The get method also takes an optional second argument defining a default value, which will be returned when the key doesn't exist, as shown below. Constant db host this config service.get string. We get database host. If that does not exist, we have localhost. Config service has two optional generics type arguments. The first one is to help prevent accessing a config property that does not exist. Use it as shown below. Interface environment variables port number timeout port number timeout string. Somewhere in the code we have constructor private config service which is of the type environment variables. Const port equals to this config service.get port infer true. TypeScript error. This is invalid as the URL property is not defined in environment variables. So if we had const URL this .config service.get URL infer true, this will be an error. With the infer property set to true, the config service get method will automatically infer the property type based on the interface. So for example, type of port equivalent to number if you're not using strict no checks flag from TypeScript, since port has a number type in the environment variables interface. Also, with the infer feature, you can infer the type of a nested custom configuration objects property even when using dot notation as follows. So you have the constructor private config service, and then which is of the type we give an object inside it, database, another object, host string. Const db host this config service get database host infer true. Type of db host is string, non-null assertion operator. The second generic relies on the first one, acting as a type assertion to get rid of all undefined types that config services methods can return when strict no checks is on. For instance, constructor private config service, we give the type of an object port number, and the second one true. Const port this config service.get port infer true. The type of port will be number, thus you don't need TS type assertions anymore. Hint: to make sure the config service get method retrieves values exclusively from custom configuration files and ignores process env files, env variables, set the skip process env option to true in the options object of the config modules for root method. Okay, we're about halfway through on the topic of configuration. I hope you enjoyed it. I'll see you in the next one. Make sure to like and subscribe. Bye.